Okay, they're called parallel lines. Okay, they have the same slopes, just different intercepts. Okay, they'll never intersect. Parallel lines, same slope. And then the other one is when the two lines meet in a right angle. That's called perpendicular line. I just assumed it was on the same page, but I guess I'm wrong. Here we go. And they have a very strange relationship with their slopes. And put these on the same, no need for them to be on different. Oh man, I'm out of order here, so I don't want to slow a second. How'd that happen? This thing is down at the end. Sorry. Perpendicular lines are lines that meet in a right angle. Remember, a right angle from geometry is the angle that's 90 degrees. Sometimes they put a box in the drawing to show that it's a right angle. And so, here's an example of that. So I have my one line looking like the other one's slope. I want to draw a line that meets this one somewhere. I don't care where it meets, but they are going to intersect. And when they intersect, it's going to make a right angle. 90-degree angle. That's my best attempt. You draw a box to indicate it's a 90-degree angle. So the first thing you recognize is that their slopes are opposite signs. So definitely one will be positive sloping, the other will be negative sloping. So we definitely recognize that. Slopes are opposite signs. And the other thing you won't recognize it, but the slopes are reciprocals of each other. By the drawing, you can't tell, but yeah, the slopes are reciprocals. Okay. And so what they do is they say, well, if one is M1, the other one is negative 1 over M. Well, I don't like that. Why put... I don't like that at all. Whatever. Yeah, I don't like that. Why'd they call it 1? Right? Why call it different numbers? The same numbers, M1. Right? Okay, yes, if it's 7, right? If M1 is 7, then the other one, if you want to call it M2, that's fine. But it's negative 1 over 7. What's better is when they're both fractions. If one of them is negative 2/3, the other one is 3/2. Okay. If one of them is, say, a negative 4, the other one is a 4th. positive. And so, they're opposite signs, and they're reciprocals of each other. Alright, sounds good. Yeah, I don't know what they're putting the M2 down there for.
Maybe there's a second occurrence of it, the subscript thing.
Yeah, so weird. Okay, I think that's going to be right there. And I'm going to jump to some exercises. Okay. These questions say the following. Find an equation of the line that passes through the point and has the indicated slope. They don't say what form, so they leave it up to us. Copied it. It passes through the point and has the indicated slope. Well, I think if you give me a point and slope, I'm most likely going to use the point slope formula. Which will work in most cases. 30. My point is negative 8.3. My slope is negative 1/2. So I'm thinking that we should use point slope. Y minus y1 is m times x minus x1. Nothing wrong with that, since that's what we have. If they tell us they want a different form, then we'll work to just use the algebra to change it into whatever form they want. But since we're given a point and a slope, let's just use this formula. Y minus 3 is negative 1/2 x plus 8. You know, it's minus a negative like we had before. That's how it becomes a plus. And that's all fine and dandy until you get to these. That'll work great, 28 through 32. When you get to 33 or 34, that's not going to work. There's no, well, I guess it could work for 33, 35, and 36. Remember though, we already know what's going to happen with these kind of lines. One is going to be x equals a constant, the other is going to be y equals a constant. Which one is which? Which one has, what kind of line has an undefined slope? Vertical line. And then horizontal lines have 0 slope. All right, good. And vertical lines have equation x equal to a constant. Horizontal lines have equation y equal to a constant. And so for 34 and 36, doing the evens, that constant isn't just some random number. We're going to get it right off of this point. The x will be 3.